Okay, sure. If I knew I would wait this long, I'd probably put like a more interesting first slide. My name is Ervin Ruci. I suppose I should say something about myself before we begin. This talk is not really about Perl per se, but it's about a certain problem that I used Perl to solve. I've been working on various computational geometry, natural language processing, and geocoding more specifically since 2004, 2005. So this is mostly what I do, and in the last couple of years, I've been interested in location coding. Location encoding, as some of you know, is like is finding a shorter code for a multidimensional data structure, like converting X and Y to a single number. And it has attained a lot of attention lately because of several companies are trying to make location encoding into commercial products. And there was a very heated discussion on Hacker News almost a year ago about this. And that set me on the path of trying to solve this problem. And that's why I'm here to talk about it. So basically, the world is, I don't know why it's not spinning, it's in 3 dimensions. So when we're trying to represent a certain location in the world, we have to take into account latitude, and longitude, and elevation if we want to be accurate. And if we count all such, if you divide the whole world up to an elevation of 17,000 meters, which I think is sufficient, we will have about, if you can read this font, 658,000 trillion boxes of 1 by 1 meter. So if we want to encode these things with a lookup table, that's not practical. We have to figure out a way to deterministically generate these codes and to be able to feed them into some reasonable fast database. So a little bit about location codes. There is a lot of other location codes. You probably are very familiar with geohash and geohash 36. There are map code, like plus codes are from Google, and you can see them on every Google map that you open these days. There is X address, a few other open source ones. There is what 3 words, that's another patented system, and zipper and OK Hi. There's many to count. I did my research, and there is much more than this, but just to give you an idea that a lot of other people are working on this problem, and some of them are actually commercial companies that have raised hundreds of millions of dollars to build commercial products about that. So this cartoon is very much necessary to understand what's going on. Everybody's trying to come up with their own standard, and some of them are trying to build the standard and commercialize it by creating like a closed lookup table, and so that people can pay to use it. I don't know if you can read this font, but you probably are familiar with a standard. So let's say there are 14 competing standards, and that's ridiculous. Let's just build a standard that will rule them all. So now there are 16 competing standards. And there is none in 3D. I did look long and hard. Maybe one of you will prove me wrong, but nobody has done a location encoding scheme in 3 dimensions yet. So I built this module, Geocode XYZ, is the extension of the previous Perl module that I produced a few months ago, Geocode, and I presented that at FOSDEM in February. And while I was presenting that, a friend of mine, Ferenc Erki, came up with a question afterwards and said, how about 3D? And here I am. It'll be in the next Perl conference, if there is any use for that. And this one has a 1 meter by 1 meter by 1 meter resolution. Even the other 2D versions that I showed you before, none of them has such a high resolution. The smallest one, I think, is 3 by 3 by 3, which is what three words, I think. And OK High has a 3 meter resolution as well, whereas Google Plus Codes, I think it's 9 meters. So basically, the idea is the smaller the resolutions, the more encoding words you need to produce the code, obviously. And people say, OK, 10 meters by 10 meters is good enough. However, you have a small New York apartment, 3 by 3, and that's 10 meter by 10 meter probably will not work in that case. So I think 1 meter by 1 meter is the best choice to represent locations with encoding schemes. So you're probably familiar with space fitting curves, and this is the Hilbert curve in 3 dimensions. Unfortunately, it is slow to implement in Perl. So I built 2 versions, one with Hilbert curve and one with just bit interleaving, the Z-order curve. The second one is way much faster. And this one, another problem with this is that you're dealing with very large numbers. These integers are huge, and you're doing it with perl5, so you have to use math begint with the GMP library or something like this. Maybe after this, my next experiment is to do this in perl6, which has native support for big numbers, and compare the performance of the two. And that should be an interesting topic to revisit at a later date. So basically, what our 3D location codes look like this: Team To TWAB, which was my acronym for there is more than one way to write a bio. That's actually a location if you click on it in the middle of the ocean. Whereas Riga Friday today is somewhere close to where we are right now. So basically, these location codes are built in such a way that it takes actual geography into account. So this area here, and probably even outside of Riga, some rural areas as well will be called Riga, whereas let's say something in Moscow will be called Moscow. The first word will always be representative of the most prominent geographical name in that area. Unless we are in the ocean, it has been pre-computed already, and it just uses a data structure inside the code to compute the correct location name for the actual geocode.
Can I ask a question?
Sure.
How do you weight prominence?
According to population. So I went to geonames.org, and geonames.org has population counts for every name, so I ordered them by population. And Tokyo would be first, I think, and in this area, Riga is the most populous country, so I compute an index based on that, and I pick that instead of.
I mean, in the United States, there are loads of towns with the same name.
Yeah, well, that's the other thing. So these names have to be unique, otherwise the encoding will not work. And I'll get to it in the next slide as well, because not only unique, but also sufficiently distinct from one another, so that when you transmit them over audio, you don't incorrectly get the other one. So, like what happened in the United States, there is Springfield. There's going to be only one Springfield, the biggest of them all. If there is another Springfield somewhere, I will not use that name, but I will try to find another name, well, the second biggest in that area. And the second biggest is going to be the one to win the rights of being the first word in that grid square.
And that's, sorry, I'm just thinking about all these weird edge cases. How do you do a population shifts?
That I haven't gotten to.
Names like in you have Swedish and a Finnish name,
That's a tough one, and somebody said that people could get upset or offended if I use the wrong name. It is a big problem. So what I did is in the online version, which if you have time, I will give you an online demo. If you go on the places close to borders of countries, then I use OpenStreetMap admin boundaries to pick the right name when you cross the border. So let's say you cross the border, you are no longer in Riga, but you are in some Vilnius, I don't know. I don't know if something close to the border here of a different country. And then you cross the border back and then you're Riga again. So basically I do take admin boundaries into account to solve this problem. But places with two names, Finnish and Swedish, what I do is I use this database from Kaggle, that is word frequencies in the English corpus of the web corpus, and I see which one is mentioned the most. So if there is more Swedish people than Finnish people who use the Swedish name, they're gonna win. That's democracy. I'm sorry, but I cannot think of another solution. If you can talk to me later and we can make a modification to this. So, like I said, this is basically a hashing function for locations in 3 dimensions. And it takes latitude, longitude, altitude, and gives back a geocode and vice versa. And the altitude max and min is 17,576 meters, plus or minus. It doesn't go more than that. I think that's sufficient because when I encode elevation, I always think of ground level elevation, because the actual elevation of a place can be derived from already from satellite data of the terrain, digital elevation models. You can get that information. So every information that is derivable, I don't see any point of encoding it. So when I talk about altitude, is altitude always from the ground level or below the ground level. And I also, like I just mentioned, I also use adaptive Voronoi simple polygons, of weighted Voronoi simple polygons. So if there is another big city close to Riga, it will, and the closer you get to that big city, the likelier you will get into the polygon of that next big city.
You spoke about the dams, these elevation models, but they have a 30-meter resolution. You have a 1-meter resolution. So
yeah, that's. I know digital elevation models are not perfect, but they're getting better. There is new satellite data.
And you need all those tables to interpret your height.
I know. This is another open problem I'm working on, by the way, because I ran geocoding software. I want to provide 3D geocoding software. So,
the distance from the center of the
yeah. Oh, I mean, I'm not completely set. If you want to use this software with not just the elevation from the ground level, you can. There is no problem in the software. You just have to know that if you, let's supply an elevation of 10,000 meters and you're in Mexico City, then you know that you are talking about the actual elevation of the point, not elevation from the ground level. Like, this is from the person using the software to know, not from me. I just provide an encoding function. But it will produce different names depending on your perspective. If you feed it a wrong number, then you'll get the wrong code in the end. The font, I didn't realize this is actually a web page, and command or control? Command Shift plus. It's not doing anything, yeah? Huh? Oh, beautiful.
I was so close. All right, there you go. Don't touch anything.
Oh, thank you. This actually looks much better. I was even having a hard time. So anyways. Oh, great. Where was I? Oh, use cases. This is very important. So this is an idea for your next startup. So there is a voice encoding as a use case. You can build an app that you can transmit your accurate location using voice without probability of error, or not without probability of error. Well, with a small probability of error, depending on your accent. If you have a thick accent like me, some words that you might say, they might sound like different words. So there will be probably hash conflicts, but I can probably improve on that. We'll see, and I'll talk about that problem later. Postcode systems. There are some postcodes in the some countries in the world that don't have correct postcode systems, so they could use something like that to accurately represent the locations that they need to deliver mail to. Indoor navigation. Let's say you are in a huge mall with many stories, and you want to figure out. Let's say you are in the ground level, and you want to go to the Apple store, and the app will be able to tell you, go right, take the elevator, then you go down the escalator, and you go there. These things that don't exist yet, Google hasn't even done it, although they are talking about indoor navigation a lot. But these problems we need to fix in 3D. Another one is modern delivery methods. You know, drone delivery. Pretty soon you will have a drone delivering your Amazon purchases to your balcony. And we need accurate location representation. You call Amazon and then you say, I am at Riga Friday today, and they will be able to come there. But if you try to read them, all the numbers that represent this information, it's probably harder to. And then GPS-enabled keys. This is another great idea for a startup. Let's say you have a shipment and you want to lock it so it can only open in a certain grid square. And let's say this shipment is coming to Riga, it will only open if the geocode matches Riga. But if you try to build this software and you try to I have 5 minutes, yeah, I'm almost done. Then it will be much harder to do so if you don't have a correct encoding scheme. So anyways, these are use cases, attributes. I will go very quickly. It's free and open source. It's short, relatively speaking, but it's easier to remember than those things of numbers. There is spatial locality. These points are all close to each other, and as you can see, they have similar geocodes. Then they are memorizable and distinct because the software I've built for picking the set is called an optimal set. Let's say you have 6 million place names, but you have to select only 100,000 of them that are the most distinct from each and every one. Now, I've written a Perl script about this, and I'm not very proud of it because it takes 1 week to compute the optimal set. I'm still improving it, but once I do have a good one, I'm going to upload it to CPAN, and people can experiment with their own word lists. And they have phonetic distance because they sound differently from each other. So, and they are unique. They have to be a one-to-one function, which is not the case in many other schemes, like geohash, for example, as you know, doesn't have this quality. And it's deterministic because it can be run offline without relying on an API or anything like that. And there is more than one name list that you can use. There is some things on GitHub, like English words, frequent English words. And there is another one that I did. Instead of using geonames, I can also use randomized English words, and there's another CPAN module that just uploaded yesterday, Geocode XYZN. And you can extend this further by building this list in other languages and playing around with the Leverstein and phonetic distance of the word. And somebody can maybe one day build an app, because I have no idea about building an app. And that will be it. Thank you very much.
Really speed this up with all the stuff we saw this morning.
How would you navigate within buildings? Like this cannot be based on GPS signal because you don't get it unless you are like to stick your hand out of the window long enough.
Well, there are other ways to get location inside buildings. We're using Wi-Fi signals and other things. So, I mean, this is not an area I'm very knowledgeable about, how to use signals to get location. I just use the GPS chip on my phone. But there are ways.
If one wanted to provide their own word list, how long
It depending how much distance you want from them. For example, you can have a 10 million word list, but it will be impossible to get the optimal set if you require distance of 4, like phonetic distance of 4. That means you have to change 4 sounds to get from one word to the other. For distance of 2, the word list in my case is 10 million geonames from geonames.org. This is how much they have. That's all the geonames in the world.
And the sets for the 3 parts are separate sets or overlap? Can you repeat the question?
Yeah, he said the sets for the 3 lists are different ones or is the same set. The answer is it is the same set. But the first word is always picked from geonames because it's encoded that way. Friday, Friday, Friday could be a valid code. It could be somewhere in the middle of the ocean or in the poles. But highly unlikely it will be a geographic name because it has been pre-computed in this way. Yeah?
You describe how big area is covered in Rīga.
Yes, it is. How big is each grid square? So Riga could be up to 24,000 square kilometers. But in most cases, it's smaller than that because it could be another big city next to it that will shrink Riga and create its own square.
Are these squares?
No, they're not squares. They are like simple polygons. They could be simple polygons most of the time. Yeah.
So in the middle of the Sahara, you are going to have 24,000 square kilometers.
In the middle of the Atlantic Ocean in the equator. Yeah. And I have to stop now because